Bismillahirrahmanirrahim. Exercise 5.3, question number 6. Minimize z equals to 3x plus y subject to the constraint 3x plus 5y greater than equal to 15, x plus 6y greater than equal to 9, x greater than equal to 0, and y greater than equal to 0. We start the solution with this first inequality, which is 3x plus 5y is greater than equal to 15. We name it number 1. Its corresponding equation becomes 3x plus 5y equals to 15. Put x equals to 0, you get 5y equals to 15, that is y equals to 3, so the y-intercept is 0, 3. Put y equals to 0, you get 3x equals to 15, so x becomes 5, hence the x-intercept is 5, 0. For reference point, put origin 0, 0 in 1. So you get 0 plus 0 is greater than equal to 15, means 0 is greater than equal to 15, which is a false sentence. Which is a false sentence. Means origin does not satisfy the given inequality. So origin does not lie in the solution region. Now we go for the next inequality, which is x plus 6y is greater than equal to 9. Name it number 2. Its corresponding equation becomes x plus 6y is equal to 9. Put x equals to 0, you get y equals to 9 by 6. After simplification, it becomes 3 by 2, and I'm going to write it as 1.5. Because I have to plot it on the graph paper and I can draw 1.5 easily on the graph paper. Then for y equals to 0, we get x equals to 9. Y0 gives us x equal to 9. So the point is 9, 0. For reference point, put origin 0, 0 in inequality number 2. You get 0 is greater than equal to 9, which is a false sentence. Means origin does not satisfy the given inequality. So we will write that origin does not lie in the solution region. Now we go for our graph. And first of all, we are going to mention x greater than equal to 0. Here it is, x greater than equal to 0 on the right hand side of y-axis. Then y greater than equal to 0. Here it is, y greater than equal to 0 above side of x-axis, and their collective region will be within the first quadrant. So how we will apply these two? We will just restrict our solution region in the first quadrant. And now let's plot the first inequality, 3x plus 5y is greater than equal to 15. I'm going to draw this line with the help of this point. X equals to 0, y equals to 3. This is my first point. Then x equals to 5, y equals to 0. This is the second point. Join the two with the help of a straight line. Here it is. We join the two with the help of a straight line. I'm going to extend the line on this side too. And then put arrowheads on the line. Here and here. Write the equation of the line, which is 3x plus 5y is equal to 15. And now mention which side we are going to shade. As origin does not lie in the solution region, so origin is on this side of the line. So I'm going to put the arrowhead on this side. That the solution region of this line is going to be on this side. And then I'm going to name my line. The name of the line is, as this was the first line, so I'm naming it as line number 1. Let me correct this arrow. It is not very clear. Here it is. I'm going to shade on this side of the line. Here it is. Now let's go for our second line. Which is our second line? The points are 0, 1.5 and 9, 0. 0 and 1.5. This is 1, this is 2, and here it is. In between with these two is 1.5, and then 9, 0. X equals to 9, y equals to 0. Here it is. And then join the two with the help of a straight line. Join these 2 points with the help of a straight line. Extend this line on to this side too. This is it. Put arrowheads on the line. One arrowhead here and the other arrowhead here. And then write the equation of the line. The equation of the line is x plus 6y equals to 9. X plus 6y equals to 9. Its solution region will be on this side because origin lies on this side of the line. And then I'm going to give some name to the line, and the name of the line is L2. And now we are going to shade the common region of all these four: x greater than y greater than equal to 0, x greater than equal to 0, L1 and L2. All the combined solution region of all these. So for applying x greater than equal to 0, y greater than equal to 0, I will restrict the shaded region within the first quadrant. First of all, I'm going to shade for L1. And where I'm going to shade on this side of the line within the first quadrant, that is, I'm just going to shade in this region. Let's see. Here it is, girls. You can see this is the solution region of the first inequality, starting from here and then this and then this. Now what I'm going to do, I'm going to shade for the second inequality. Its corresponding line is L2, and where I'm going to shade on this side of L2 within the first quadrant. Let's try it. Here it is, students. You can see I have shaded above side of L2 within the first quadrant. And now you can see this darker portion, it is showing the combined solution region or the common solution region of the two inequalities. And now let's mark the corner. Let's see where it is. It is starting from here and then this and then this and then this side. And now let's mark the corner points. This is our first corner point. Let's name it as A, and we can see its coordinates are y equals to x equals to 0 and y equals to 3. This is our second corner point. Its name is B, and it is the point of intersection of L1 and L2. And this is our third corner point. Let's name it C. Its coordinates are 0 and 9. Now let's write these corner points. The first corner point is A. Its coordinates are 0, 3. The second corner point is B, which is the point of intersection of L1 and L2, and the corner point C, which is 0, 9. Now let's find point B as the point of intersection of L1 and L2 by solving L1 and L2 simultaneously. Here it is. Here you can see L1 is 3x plus 5y equals to 15. L2 is x plus 6y equals to 9. You multiply L2 by 3 and subtract L1 from it. As a result, we get y equals to 12 by 13. Put in L2. This is it. Perform simplification, take LCM, this and that. And as a result, you get x equals to 45 by 13. Hence, the corner point B becomes 45 by 13 and 12 by 13. Let's write it on our graph paper. The corner point B is 45 by 13. Here it is, 45 by 13 and 12 by 13. This is our third corner point B. Now let's get to the work, the question, which was to minimize this given function with respect to the constraints. So what we are going to do, we are going to put all these corner points one by one in this function and see which corner point gives us the minimum value. Here it is. The first corner point is A, which is 0, 3. Put x equals to 0, y equals to 3. As a result, you will get 3 into 0 plus 3 equals to 3. Then put the corner point B, which is 45 by 13 plus 12 by 13. Excuse me, not plus, but there is a comma here. 45 by 13 and 12 by 13. So I'm going to put x equals to 45 by 13 in it, and y equals to 12 by 13. Perform simplification. As a result, you are going to get 147 by 13. Perform this simplification by yourself. As a result, you will get 147 by 13, which is equal to 11.3 approximately. Then we get to the third corner point, which is C90. So put x equals to 9, y equals to 0 in it. As a result, you get 27. So let's decide which value is the minimum. Which one is the minimum value? Let's decide it now. 3, 11.3 and 27. Of course, this value is the minimum value. So we are going to write our answer now. This is the minimum value. So let's write our answer. Hence, z is equal to 3x plus y is minimum at the corner point. What is the corner point? A 0, 3. And this is our answer. That completes the solution. And now I'm going to show you the picture of the actual graph paper so that you may have an idea how you're going to sketch it on a routine graph paper. Here you can see, students, it is the graph paper, and I have drawn the graph of the particular question using the scale 4 small scale equals to 1. Here I have taken 4 small scale because I have to take I have to plot 1.5 on it. So if 4 small scale equals to 1, so 0.5 will come after 2 small scale. So you can see I can draw 1.5 easily here. And this is the first line, this is the first line L1. This is L1. And this is the second line L2. Here, this arrow mentions y greater than equals to 0. This arrow mentions x greater than equal to 0. And this is the collective solution region of all the 4 inequalities. And this is the corner point A. This is the corner point B. This is the corner point C. And that's it.